Hello and welcome to lesson number 5 in Unit 0 Algebraic Tools in our grade 11 University College math class. This is solving literal equations. So, solving literal equations, we're going to finish up the unit with this. This sort of reinforces your ability to isolate a variable. Usually when we see variables, we're not necessarily used to seeing lots of them kicking around. However, whether there are lots of letters or very few letters, the rules remain essentially the same, which is to isolate a variable, we are going to perform the operations of BEDMAS backwards. So we're going to start by undoing addition and subtraction, follow that by undoing multiplication, division, follow that by undoing any exponent stuff, and lastly going to be the brackets. So let's look at our first example here. So here we have, and if you want to pause and copy this down, now would be a good time. If you don't, that's fine too. So we're trying to solve d equals r times t for r, which basically means at the end we want to have r equals to something all by itself. I like to start by saying there's r. I have found it in the equation. I've already highlighted it. What is happening to r? Currently it's being multiplied by t. So how do we, and that's the only thing that's happening to it. So how do we undo that? Well, we undo that by dividing both sides by t. On the right side of our equation, multiply by t, divide by t, you're just left with an r. And on the right side of our equation, we have d divided by t, which can't be simplified because we don't know what d or t is for that matter. So when we get to that step, that's kind of the end for us. That is the answer in that we have isolated r and said that it is equal to, in this case, d divided by t. Hopefully that makes sense. Again, the big principal thing we want to catch here is that whatever you do to a number, you can do to a letter. And we always want to be operating following BEDMAS backwards. So let's work through some examples and look at a few, not exceptions, but maybe just some interesting cases for when you're trying to solve these literal equations. Let's jump over to number 2. So number 2 here says solve p equals 2l, doesn't look like an L, but that's a lowercase l, 2l plus 2w for w. Okay, so let's start by finding the variable that we want to isolate. There it is, w. So what is happening to w at this point? Well, two things. First, it is being added to 2l, and second, it is being multiplied by 2. So we want to be following the correct order to isolate this variable, and we're going to be doing this following BEDMAS backwards, which means we need to undo addition and subtraction first. So the first thing that we are going to do is move 2l over to the other side, or transpose it, by subtracting l from both, or 2l rather, from both sides. So what do we have then? Well, we have p minus 2l's equals 2w. All right, so far so good. Now we want to isolate w further by undoing multiply by 2. And how do we undo multiply by 2? Well, we divide by 2 on both sides to keep this equation equal. So on the right side, we now just have a single w, and on the left side we have, well, let's just write it as we see it, p minus 2l all over 2. Now I want to add an or here, and this isn't for any other reason that sometimes the answers in your homework are going to appear in a slightly different way, and I don't want you to panic. Another way to write this is imagine that you were to take p, which is the first part of this numerator, and divide it by 2, and then take the negative 2l and divide it by 2 as well. You might end up with p over 2 minus 2 divided by 2, of course, gives us 1l being equal to w. Now both of these are equivalent. I'm not fussy. I don't care which one you put down on a test. However, there might be one or the other in the homework, and I just want you to be prepared to see an answer in the homework that might not be exactly what you had on your own sheet, but that you're able to see that it is an equivalent answer. Okay, so that is the first, or rather the second example. Let's move over to number 3. Number 3 says solve q equals c plus d over 2 for d. Now, let's find that variable. The variable that we want to isolate is d, which is right here. Now what's happening to d? Two things. It is being added to c, and it is being divided by 2. So we got two things to undo here. Now I just finished saying we're going to follow BEDMAS backwards, and we should undo addition and subtraction first. That comes with a condition, and the condition is unless the addition or subtraction, or multiplication or division for that matter, happens in the numerator of a fraction. Because c plus d is part of a numerator that's all being divided by 2, in essence, there is an implicit set of brackets around it. So it takes that plus c and makes it not an AS from BEDMAS, but instead a B, a bracket, something that needs to be worked with and manipulated after the brackets have been removed. We can't remove those brackets until we undo divide by 2. So this is a special case, not a special case, but it's something to consider, that you have this implicit set of brackets around the numerator of a fraction over a denominator. So all that to say, we are going to multiply both sides by 2 to start us off. So we are ending up here with 2q equals c plus d. Now you'll notice that because c plus d is no longer a part of a numerator of a fraction, now those brackets have vanished. And now we are free to transpose c to the other side of the equation by subtracting c from both sides. And that's going to give us 2q minus c equals d. I like to write my variable on the left, so I'm going to do a quick little rewrite. D equals 2q minus c. There is our answer. So the big learning from this example, of course, is implicit brackets in the numerator of a fraction. Gotta save that to the very end, or till you get to brackets, I guess. Okay, let's jump over to V here. Or 4, I should say, jumping ahead. So we're going to solve V equals 3k over t for t. So where is our variable? Right here, there's t. Now, it's being multiplied by 3k. That's all right. But here's the thing. Having t in the denominator makes the whole thing a little bit tricky. So what I'm going to propose is if you have a single fraction, and if you want to, it might help to consider this to be v over 1. You can write any value over 1. If we have a single fraction on the left side of the equation and a single fraction on the right side, we call this a proportion. These two ratios are equal. And in this particular situation, what we can do is we can cross multiply. And cross multiplying will help move a denominator from help move a variable from the denominator up into the numerator. You'll see what I mean in a second. So let's cross multiply. We're going to start with v times t, so that's going to give us vt, and 1 times 3k, which is just going to be 3k. And now you notice, hey, look at that. Fractions are gone. T is a part of just my regular old equation. How do I isolate it? It's being multiplied by v. I'm going to isolate it by dividing both sides by v, and then t will equal 3k over v. There we go. So cross multiplying, great strategy, highly recommend it. It'll work kind of more often than you think it might. Let's have a look at example 5, speaking of that. Example 5 is solve a equals pi r squared s divided by 360 for capital S. All right, so there's the variable we're looking for. We're going to isolate that. Two things are happening to it. Seems like more, but here's my thinking is that if it's being multiplied by pi r squared, we could consider that a whole entity. Yes, it's being multiplied by pi. Yes, it's being multiplied by r, but we can sort of lump all those together if it's all the same operation. It's also being divided by 360. Now, as I said in the last example, we have one solitary fraction on the left and one big but solitary fraction on the right. That is a perfect opportunity for us to do some cross multiplying, which is what I'm going to recommend right now. So let's cross multiply. We have a times 360. That's going to give us, oh, let's not do hot pink. Let's do 360a. And then we have 1 times pi r squared s. All right, no fractions. This is looking great. How do we isolate s? Well, it's currently being multiplied by pi r squared, so we are going to divide both sides by pi r squared. That's going to give us 360a over pi r squared equals s. And we'll just keep it this way for now. Video is getting a bit long, so we'll forsake a little bit of my rewriting. And there you go. Let's do one more example, actually 2 more. One more that's on the page and one more I'd like us to add. Let's jump over here to 6. So 6 says solve a equals little a plus b times h all over 2. We're trying to isolate little a. Little a is right there. It has 3 things going on right now. It is being added to b, it is being multiplied by h, and being divided by 2. Now again, we got the brackets. They're obvious this time. They've drawn them in for us. So again, I'm going to recommend cross multiplying here. This just works out nice. So if we were to cross multiply, we would do a times 2 and 1 times the rest. So let's get that happening. A times 2 is 2a equals bracket a plus b times h. Next thing we want to, of course, tackle before brackets is how do we undo multiply by h? We are going to divide both sides by h. So we have 2a over h equals a plus b. Now that it's the only thing over there, we can drop the brackets out. And we're trying to isolate a, I think. Yep. So how do we transpose b to the other side? We are going to transpose it by subtracting b from both sides. And that's going to give us 2a over h minus b equals a. And that is our answer. Now, I want to point out, this is like a nitpicky thing, but it's super important at its heart, is that some students will put 2a minus b and sort of like retroactively put like the whole thing over h, and that is wrong. And it's wrong because at the time that you moved b over to the other side of the equation by subtracting b from both sides, it had already been divided by h. That's the whole point. You don't want to double divide it by h. That's not right. You have to do the same thing to both sides to keep them equal. So for us, it's a nitpicky thing, but I see it all the time. Please, please, please mind the order in which you do things. And if you subtracted the b after you divided by h, don't make it a part of the numerator. It's its own term. Okay, getting real long in this video, but I want to do one more write-in example. So I'd like you to write this one in. It shows up in the homework, which is why I wanted to include it here. So I've written out the Pythagorean Theorem, c squared equals a squared plus b squared for b. So I want to isolate b. What's happening to b? Well, there is b right there. A couple things are happening. First, I can see it's being squared, and then it is being added to a squared. So let's follow BEDMAS backwards. And we are going to start by subtracting, let's transpose that first. We are going to transpose a squared to the other side by subtracting a squared from both sides. That's going to give us c squared minus a squared equals b squared. I'm going to rewrite this. I don't care if it takes an extra second. It's just a little bit easier in my brain to handle it if I write it this way. What you can do, by the way, that's one of the properties of an equality, is that you can write the left side in the place of the right side, which I've just done here. Now, how do we undo something being squared? Well, we are going to square root it. And once we square root it, the square root of b squared is b, and the square root of c squared minus a squared, this isn't really an easy thing to do. It looks like it should just be c minus a, but it's not. We've just done a whole bunch of lessons on factoring, and we know that that's not true, since c minus a times c minus a does not give you c squared minus a squared. We know that. So what I'd like us to do is just rewrite it as it is, but I want you to include this plus minus value here in front of the radical sign. And I want you to include that because when you're squaring things, two positives will result in a positive product, and two negatives, when multiplied together, will result in a positive product. So we don't know which one's which. It's super important to have this plus minus here. Definitely a mark coming off if you don't include it. So please do. Whew! There it is. That is the end of lesson number 5. It's the end of unit 0. Good luck with the homework. Again, it's just on a worksheet here on the next page. The answers are on the side. If you get stuck, reach out via email, or come to our video chat, see me in person, whatever works for you. Get the help you need to finish up the homework. Good luck on the assessment for Unit 0.